Okay, today we're going to look at derivatives of exponential and logarithmic functions. This is in section 4.4 of your textbook, just for a reference point. I am going to start with the exponential, and we're actually going to start with the function y equals e to the x. And if you look at that, I'm going to spare you the proof of this, but I am going to remind you that we actually sort of discovered this when we were doing a question in one of our review packets, I believe it was last chapter, where you had to match a derivative to the graph of the derivative to the graph of the function. And we came upon the discovery that if we had a function that looked like this, so I'm sketching out my y equals e to the x graph, if you kind of talk yourself through the derivatives here, well, at 1 it appears that my slope of my tangent line would be about 1. And prior to that, if we're to the left of that, x value is less than 1, my slope is definitely going to be less than 1. It's going to be some really small fraction, 1 over 3, 1 over 5, 1 over 20, really small fraction but positive. So if I start to plot those points, it looks something like this. And then if I go to the right, x value is bigger than 1, I've got positive slopes, increasingly positive, and they start to get pretty steep as I get further and further away from 0. So if I start to plot steeper and steeper, I get something like that, and of course I'm estimating here, but your derivative does end up coming out to be the same as your original function. So that's just kind of the thinking and making sense of it. If you wanted to pull up your derivative tracer that we have that's in your Schoology folder, that we use the GeoGebra applet, that would allow you to also type in e to the x, and it will actually plot them a little bit nicer than I just did. Okay, but we're going to pick up with what's your formula, and let's go ahead and practice using it. So if we go to, I'm just going to go ahead and write down nicely what we know. You're going to have quite a few rules, so you might want to organize this for yourself. You should have altogether 8 rules by the end of this section. So derivative of my function e to the x, we can put that in parentheses if we want, is simply e to the x, rule number 1. And while we're here, now that we did the chain rule, as we do our derivative rules, you're going to have a second rule for every rule that we have, because we have what if we have the possibility that our power is not just an x, that it's some function, which I'm going to call u. So if my function is e to the u, my derivative is then going to be e to the u, just as if it was e to the x, but now I need to follow it by du dx, because if I'm differentiating with respect to x, and I have e to the u, I've differentiated with respect to u, I've got to multiply that by du dx. So that's just my chain rule kicking in there. And it's really the same derivative, but I'm going to write it as a separate rule so that we now have a direct place to go if we have something besides an x as our exponent for our function e to some power. So with that, I'm going to look at some examples. So make sure you've got those written down, and then let's do some examples. So number 1. Let's suppose our function is y equals e to the 2x, because I'm really going to start right in with the chain rule. Y equals e to the x is always, derivative is always e to the x. There's nothing else I can say. Super simple. I guess I could put a number in front of it, and I could say, yeah, let's actually go back. And let's make our first example y equals 2 times e to the x. And if I differentiate that, I'm going to get, I've got 2 times my function e to the x. So derivative is simply going to be 2 times e to the x. That constant out front just gets multiplied by my derivative, which is of course the same as the function. Okay, now on something more interesting. So let's go back to y equals e to the 2x, and now let's make the 2 part of the power. So with this one, my power is going to be my u. So I'm going to have u is 2x. Du dx then is 2. So when I have my chain rule kicking in, I'm going to have y equals, or dy dx, sorry, equals e to the u, so that's e to the 2x, it doesn't change, it's exactly what I had for my function, times du dx, and the du dx is 2 in this case, so times 2. Normally, of course, we're going to write that as dy dx equals 2 times e to the 2x and put that 2 out front, just because that looks a little bit better to us. Okay, so that would be a pretty basic example where I have a power something other than x. Let's keep going. So let's suppose my function is e to the negative x over 4. I'm going to make u be my power, and then I'm going to go ahead and differentiate u with respect to x. And I'm really thinking right now that that's a constant times x, negative 1/4 being my constant. That might look better if you write it that way, negative 1/4 times x, so derivative is just negative 1/4. Let's do my derivative. So dy dx is equal to e to the u, which is e to the negative x over 4, times du dx, which is this one, negative 1/4 is what I'm multiplying by. So altogether, dy dx equals negative 1/4 times e to the negative x over 4, or we might write that as negative e to the negative x over 4 all over 4 is most likely how you will see it written. Okay, I'm thinking let's do maybe 2 more examples. You know what, I'm just going to go to each. So that was 3 examples. Let's go ahead and do y equals e to the x squared. Looks maybe possibly a little bit intimidating, but don't be intimidated by it. We're going to do the same process. We're going to let u equal x squared, that part that I don't like, because I know if it were just y equals e to the x, my derivative would be e to the x. So what is it if it has e to the x squared? U is x squared, then I've got du dx would be 2x, and then my dy dx would be e to the x squared, rewrite exactly what I have for my function, and then follow that, of course, by my du dx, which is 2x. So 2x e to the x squared. Notice at the end I'm just putting my other function in front of the e to the whatever power, just because that's sort of standard notation. Okay, I think one more example will do it here. Let's make it a good one. Y equals x squared times e to the x minus x times e to the x. And this one is definitely looking a little bit more complicated, although my e terms are not complicated. In fact, these are the simplest we've had. We have no u in terms of e to the u. We really just have a simple e to the x. So my derivatives of those are just going to be the same, e to the x. If I'm thinking derivative of e to the x, it is e to the x. The complicated part of this is my product rule. So this is really going back to how do I apply a product rule, and we actually have, in this case, it does look like we have 2 product rules, because we're going to have a product rule there. I've got x squared times e to the x, and then I'm going to have another product rule right here. Okay, so that is the challenge of this problem. So let's go ahead and do product rule number 1. So I'm going to have first, which is x squared, times derivative of my second. So derivative of e to the x plus e to the x times derivative of x squared. I haven't actually done the derivative yet. I'm just kind of keeping track of what I'm doing to organize. So let's see if I can move this and maybe shrink it just a little bit, give myself a little bit more room. And now let's go ahead and write out the second part, then I'll do all my derivatives. So my second part here is going to be my product rule right here, which is going to be minus, I'm going to use brackets to set this off. X is my first function times derivative of e to the x, my second function, plus my second function e to the x times derivative of x. And that's all my second product rule right there. So now I just need to actually go back and take the derivatives. So let's see, I'm going to have x squared is the same. Derivative of e to the x is e to the x. So there's your actual stuff from this section kicking in, plus e to the x times derivative of x squared. That is good old power rule, times 2x. Minus, I'm going to go ahead and leave all of that in brackets for now, or parentheses. I'm going to have x times derivative of e to the x. So here's my new part, just like I had over there. It's going to be e to the x plus e to the x, no derivative. And now I've got to do derivative here. Derivative of x is just 1. So step 1, I wrote it out. Step 2, I actually took the derivatives. Now let's see what we ended up with. So I'm ending up with x squared times e to the x, plus I'm going to put the 2x in front, 2x times e to the x. And now I'm going to go ahead and distribute the negative through. So minus x times e to the x, and then minus 1 times e to the x at the end there. I'm just going to look and see if I can combine any terms. X squared e to the x, I've got a plus 2x e to the x, and then I've got a minus 1x e to the x right here. Those would be like terms. So I can actually combine those two. Plus 2 minus 1 is going to give me plus 1. So I've got x squared e to the x plus 1x e to the x minus e to the x. And that's going to be my final answer. Okay, definitely a little bit more challenging, but notice that the challenging part was not the new stuff. The challenging part was applying the product rule, and things just got a little bit more complicated.